Chapter 3 Applications of Trigonometry. Vectors, the polar form of complex numbers. Now, we will start with the vectors and we will give some basic definitions, vector operations, and dot product. And in physics, there are scalars and vectors. Scalars are the quantities which can be represented by a numerical value, and vectors are the quantities then which can be represented by a numerical value plus a direction. So here scalar is just it has a numerical value. It's like the height, for example, but the vector here is it has a numerical value and a direction. So it's like force. Most of the time the force is a vector here. I mean vector in physics, and velocity is another one, and the acceleration is another one. These are most of the time they are used in physics, but here in mathematics we will see just mathematical. I mean, we will take it as a just mathematical point of view. Okay, vector represented by a directed line segment. We will use a line segment, so it will start from somewhere, a point, and the magnitude of the vector is the length of the segment here. The magnitude here is this. The length here is called the magnitude of the vector, and the direction of the vector is the direction of the line. So you see this is the direction here, so this way. A vector with initial point A and the terminals point B is denoted by AB or AB with an arrow above AB, over AB, and sometimes we use we don't say AB, we just say this is U vector or V vector, but it will be bold. So these are like the vectors here, U vector, V vector, AB vector. So these are different vectors. Now, two vectors are equal if they have the same magnitude and the same direction. So it means like if you have two vectors and if they have the same direction, so and they have the same length, so they're equal. So as you see, A, B, and C, D, indeed, parallel vectors, we can say the parallel vectors, no matter where the initial point is, the parallel vectors have the same direction, and if their lengths are same, their magnitudes are also same. Okay, the parallel issue is not exactly true indeed. One vector can be like this, the other vector can be like that, but they're not equal. Not equal because their directions are not same, because this is going this way and the other one is going this way, so they're not equal. So parallelity is not showing the equality, because they can be parallel but in different directions. Okay, a vector with initial point at origin is called position vector, and the position vector V of a vector AB with initial point x1, y1 and the terminal point x2, y2 is given as AB, the vector AB, let's call it V, x2 minus x1, y2 minus y1. So here we have an initial point x1, y1, and assume the vector is starting from this point and ending at x2, y2. Now this vector, we can write this vector, we can show this vector this way. the first component and the second component of the vector. So let's find the position vector for AB and BA. So indeed, we just take, okay, indeed, you do it this way. If this is AB, so you take B minus A, kind of, okay? And so you take the values of -2, okay, -2, and the value of A, 3, and the y component or y coordinate of B minus y coordinate of A. So if it's a BA, so you say B minus, okay, A minus B. So you're taking the coordinates from A, then subtract the coordinates from B. Now let's do the try and check. The position vector of vector with initial point for A 3 and the terminal point -5B is 4, 7. So find the values of A and B. So initial point is A 3, and B is -5B. Now the vector here is this vector, let's call it U vector, this one is 4, 7. Now how can you find this vector? I mean AB vector is, now AB vector is 4, 7. So how can you find it? Well, let's say this is AB vector. So it starts from A and ends B. Now how do you find the components of the vector? So you subtract, you take B minus, okay, the x component of B and the x component of A. Now B minus 3. So then if two vectors are same, so their components are same, so it means -5 minus A is equal to 4, and then this will give us A is equal to -9. And in the same way, 7 will be B minus 3, and this is B is equal to 10. So it will be -9 and B equal to 10. Now, horizontal component and vertical components, here, this component, the first component of A, of the vector, is called we call it horizontal component, and B is the vertical component. A and B are called horizontal and vertical components of V. And okay, by the way, here, when we say this one, think of this vector, put in, like, we will assume in the Cartesian coordinates system, we will assume it starts from 0, 0, and it goes up to AB. So for this vector, we will say this vector is vector AB. Okay, when we say this type of vector, and you can think of this here, it starts from the origin and it goes up to AB. So this A will be its horizontal component, and B will be vertical component. Now the magnitude here, the magnitude of this will be, as you see, the magnitude here will be the length of this arrow. So which can be calculated by using this formula here. If it is AB and 0, 0, using the distance formula, we can get its square root A squared plus B squared. So we call this one the magnitude, and we just write it as absolute value of V. I mean, it looks like absolute value, but this is standing for magnitude. Okay, from now on, we will assume all the vectors. When we give you a vector, AB or 2, 3, you have to think of this one as 2, 3. Like this is the vector starting at 0, 0 and ending at 2, 3. So you have to think of the vector this way. And you have to think the vector is just placed at the origin of the Cartesian coordinate system. If you think of the angles, it will be in standard position. So from now on, I mean, our information will assume, all the information we give you will assume the vector is located at the origin. So it might be like this, it might be like this or like this, or in, we have 4 quadrants. So the vector will be in one of the 4 quadrants or on the y or x-axis. So related to this issue, we can talk about the angle. The positive angle between the vector v and the positive x-axis is called the angle of direction. So it comes, so it behaves like a terminal side of an angle. So if you have an angle like this, if you have a vector like this, v vector, so this angle will be our theta. So the theta will be here, the direction angle of v. If this is the case here, okay, if this is the case, if v is such vector here in this direction, and this will be our direction of angle. So the direction of angle vector, the direction angle of v. And in the same way, if the vector is here, so we will say this theta here is the direction angle of v. Or it might be in the 4th quadrant, or it might be here. So okay, let's take this one as the vector here. Vector will be vector can be in the on the y-axis also. So this theta 270 will be the direction angle, or it might be here, like v is here. So it will be theta will be this angle now. So theta will be direction angle of v. Now, at the direction of angle, how can we find it? So assume we give you the coordinates of the vector, or the components. We can say the horizontal and vertical components of the vector. And we want to find theta, and theta is the direction of the angle v. So first we start with the reference angle of theta. And how can you find the reference angle of theta? You just look at the tangent inverse of the absolute value of b over a, then say this is alpha, and then theta is, if AB is in the 1st quadrant, it will be alpha. If AB is in the 2nd quadrant, it's 180 minus alpha, and then if the quadrant is 3, if AB is in there, so it has to be 180 plus alpha. And so this resembles like an angle whose an angle in a given in a quadrant, and its reference angle, and then we want to find this angle. So here we find the reference angle, we check the point if it's in which quadrant is it, then depending on the quadrant we try to get the angle from the reference angle. Now here is the situation. As I said, you will assume all the v given by this, you will locate them at the origin as the initial point, and ending point is AB, and theta will correspond to this, or sometimes this, or sometimes this, or sometimes it's this, as I said. So this alpha equal to tangent inverse B over A, the absolute value of B over A will be the reference angle of the direction angle of the vector. Now let's find the magnitude and the direction angle of V. So for the magnitude, it's very clear. Take the square of the first component, take the square of the second component, and add them, and then take the square. This will be 4, the magnitude. And for the direction angle of V, we have to find the reference angle first. Okay, what's the reference angle of the direction angle? So we just said alpha is equal to tangent inverse B over A. Okay, B over A, and it's take its absolute value. So it will be tangent inverse square root 3, which is 60 degrees. Now, the point here, you look at the point here. Where is it? It's in quadrant 2 minus 2, 2 square root 3. And now the reference angle is 60, so it has to be under 20 degrees. So as you see, it will be under 20 degrees. Okay, let's do the try and check there. Find the magnitude and the direction angle of the following vectors. The direction of this vector here, the magnitude will be, for sure, it will be 2 squared plus minus 2 squared, and take the square root. That will be square root of 8, and which gives you 2 squared 2. And the reference angle will be what? The reference angle will be tangent inverse of the absolute value minus 2 over 2, which is B over A, and then it will be tangent inverse 1, so which is 45 degrees. Now this here, 2 minus 2, so the end point of the vector is in x is positive, y is negative, so it has to be in the fourth quadrant. So theta will be what? 360 minus 45 degrees, which is 315. Okay, when it comes to this question here, when you calculate this one, you will get the magnitude as 5. Okay, you can take squares and squares, and I think it's not hard to see this is equal to 5. And the alpha, the reference angle of the direction angle, is minus 4 over minus 3, and this will be, sorry, this is not the alpha. It's just tangent inverse of the absolute value of minus 4 over 3. This will be, okay, when you use a calculator, it will be about like 53 degrees. Okay, this is about 53 by calculator. And so this is in quadrant 3. So then theta, the direction angle, should be 180 plus 53 degrees. So it will be 223 degrees. No, it's 233 degrees. Okay, I don't have much space here. So the magnitude of the last vector is, if you do it, let's see, it has to be 2 squared 2, and then alpha will be tangent inverse of 2 over 2. It's equal to 45 degrees. And 45 degrees. And 2, 2 is in the first quadrant. So which angle has the reference angle 45 in the first quadrant? So the angle should be 45 itself, because in the first quadrant, the angle and its reference are same. Theta is equal to alpha in the first quadrant. So the direction angle will be 45 degrees. Now, the relation between the direction angle and this AB is given as A equal to the length of V times cosine theta, or the magnitude times cosine theta, and B is equal to the magnitude of V times sine theta. This is very normal because if you have this one like in the unit circle, it goes like in the, if it is 1, minus 1, and okay, so it goes like plus 1, it's 1 here. So any angle theta has this cosine theta, sine theta, right? This components are here, cosine theta and sine theta. And if you want, if you do it with the V, the length of V, and you bring it to here, so it will be then, it will be, when you multiply with V here, you extend it to the absolute value, the length of V. So if you change this one as the length of V, here, this one, it will be the absolute value of the length of V again. The radius will be V, but this time the components will be definitely V cosine, no, sine theta, and the norm of V, or the magnitude of V, times this one here, cosine theta. Now, okay, in the first quadrant, this is the situation here. This is V, the absolute value of V, and this is theta. So we can say this is A times V times cosine theta. Now you can use the, this is easy to see because cosine theta is what? The cosine theta is, if this is A here, so if this is A here, A over absolute value V, the length of V is equal to cosine theta. And now A, you can set up this and you multiply these two and you can get A is equal to the length of V times cosine theta. So this is coming from this fact here, the triangle, the right triangle, the trigonometric ratios of a right triangle. Now sine theta is the same way also. Now if the vector V has the magnitude of 20 and the direction angle of 210, so how can we find the vector? So the vector, we will find the vector as the vertical and horizontal component. So what are these values? Now from from here, we know it has to be, this A has to be equal to the length or the magnitude of V times cosine 120, and B has to be the length or the magnitude of V times cosine, okay, sorry, this is 210, and this has to be sine 210. Okay, this will be 2 times 20 times what is cosine 210. Okay, look at its reference angle. We know how to calculate this. This is 30 degrees now, and it will be equal to cosine 30 degrees, but here it will be cosine is negative here, so it will be negative cosine 30. Negative cosine 30 is negative square root 3 over 2, and this will give us negative 10 square root 3. And you do the same thing for sine 210, and sine is negative also there, so but the value of sine 30 is 1 or 2, so it will be minus 10 here. So okay, let's see the slides. Okay, as we did here, so the only thing, your problem might be this one, and we teach you how to do it like 210, so you will find the reference angle. If the reference angle is 30 degrees, and we know cosine 210 is equal to cosine 30, but cosine is negative here, so you say it's negative. And sine is also negative here, so you write sine 210 is equal to negative sine 30. And we write here minus square root 3, minus square root 3 over 2. And here this one, negative 1 over 2. And then you calculate these components, and we get negative 10 square root 3 and negative 10. Now let's do the try and check. And it says the vector v has a magnitude of 8 and a direction angle of 5 pi over 3. Okay, it's better we change this 5 pi over 3 to degree, and this has to be something like 300, I guess, because it's 180 times 5 divided by 3. It has to be 900 divided by 3. You can check. So the components will be A will be v times the magnitude of v times cosine 300, which is 8 times cosine 300. Okay, its reference angle is cosine 300. Its reference is 60. It has to be 8 times cosine 60. And then this cosine is positive here, so it has to be positive cosine 60, and this will be 8 times sine 1 over 2, it will be 4. And B, the magnitude times sine 300, 8 times sine, sine 300, and this will be 8 times sine 60. But the problem here is sine here is negative, so all STC, so sine negative, so it has to be this. So 8 times negative square root 3 over 2 will be minus 4 square root 3, and then our v will be 4 and minus 4 square root 3. So this is the the components of the vector. Now we will talk about the operations on vectors. Assume we are given two vectors and with their coordinates, not coordinates but components, let's say. Okay, if we say coordinate, it means like these are like points. No, these are not points, these are vectors. And k is a scalar, k is just a number. We can add two vectors and we will get another vector from it. And you know, when you add two vectors, you add the horizontal components and then vertical components, and you put comma, and you use the vector notation here. And multiplying with a scalar multiplies each component with the scalar. And b minus w, when you subtract the vector, it means you subtract the vertical and horizontal components. And the first one is belong to v. These are from v, and these are from the second ones from w. Now let's see those. These. Let's perform the operations, and I think it is easy to do. So like if you subtract these two, and you will get 7. 2 minus 1, it makes 1. 2 times v, so first you do the scalar multiplication first. 2 times 4, 2, minus 3 times negative 3, 1, this is w here. And then first you multiply these two, so it will be 8. Okay, let's do it here. 8 and 4, minus, multiply with 3, so you got minus 9 and then 3. And then you subtract, so it will be 8 minus 9 for the first component. For the second component, we have for minus 3. This will be 17, comma 1. And the same thing happens in the other one, v plus 4w. You can multiply with 4 and then add v. Okay, so you multiply these, then you add component wise, and it will give you -8 and 6, but we take the magnitude. So this here for the vectors, it means the magnitude. And how do we calculate the magnitude? We take the square of the first component and the second component, and they add them, and then take the square root, so the magnitude will be equal to 10. Okay, for these, okay, these are not hard to do. Just stop the video, try to do it yourself. So I will do it quickly. So 3u will be like 12, 6, and minus 2w. 2w is like 6, minus 8, and then this will be like 6, and minus 8 to plus 14. So this has to be, if I'm not wrong, it has to be this. And let's look at this one here, 4, 2, it's minus 4 minus 2. This one plus v minus w, so I can say here minus 3 plus 4, so it will be like minus 3 plus 4, so I can subtract with -1, then add, okay? So it will be -4, -3, -3, so it has to be -10. And this one will be -2, 1, 4, will be 5 minus 2, 3. So you take its absolute value, it will be 109 square root. So check this one, please. Okay, check if it is true or not. Okay, what is the geometric interpretation of the addition? So if you put your vector here, u vector, and v vector here, when you add them, you will get this vector. So how do you get this vector? There are two ways of it. Like you can move it to here, and you put this v. So u starts, and then so u ends, you put v here, and it will give you the last one. So this vector becomes u plus v. So basically you make a parallelogram with u and v, and then you make the diagonal here. Or as I said, you put u plus v, you put u, then add it as v. Like you will connect them this way, like the one u ends, you put v starts here, and now this becomes u plus v. This is another way to show it. Okay. And if k is positive, multiplying with k, multiplying the vector with k, it might change the direction, it might change the magnitude, it might not change the magnitude, it might change the vector only. So here is the situation. Depending on the value of k, if k is positive, so the resulting vector kv is it will be in the same direction as v, but it will be k times magnitude of v. So if you have v, if you have 2v, so they're same in the same direction here, but it will be doubled here. Here it's doubled, the magnitude or the length doubled. And if I say it's the if 1/2 v, it will not change the direction, but it will make the half of v. You see, we have two pieces here, and this is one piece. I mean, in terms of length. And if it is -2, it changes the direction. So as you see, they go this way, but this kind goes this way, but the length will be doubled length. And if it is -1/2v, so the length will be half. You see, when you compare to v, it's the half length, but when it says minus, so it goes this way, not the other way. This is v goes this way, but just the opposite. So if you multiply with minus, Yeah, you are changing the direction of the vector. Now, if a vector can be written as a scalar multiple of another vector, and these vectors are parallel. So these are parallel, or these are parallel. A vector with magnitude 1 is called a unit vector. So this is important. Now, the question here is this. So if you have a vector v, it might be any length, okay, any length, or any magnitude. So what is the unit vector? So this is the unit vector in the direction of v. So how can I find this one? How can I find the unit vector? Unit vector means its magnitude here will be 1. The length will be 1 here. So the length of this vector will be 1 in terms of length. But the direction will be same as this one. So how can I get this one? So this is the question. So this formula is telling you the answer. So it says if okay, if v is a non-zero vector, then you can directly do this calculation. Calculate 1 over the absolute value of v. This is a scalar here. Scalar, this is just a number. Multiply with v. So it will be a unit vector in the same direction as v. So this type of unit vectors are used in physics and mathematics in several occasions, in several topics. Now find a unit vector in the same direction as v. So what we do here is just find 1 over v. Okay, v, the absolute value of v is 5. You can check. And then it will be 1 over 5 times v. So what does this mean? You multiply with the scalar inside the components with the scalar, so you will get this one. So this is what I tell you. Find a unit vector in the direction of this. So if you calculate this, check this one, please check. I'm doing it. So it will be 13, and the direction okay, the direction in the vector in the direction, the unit vector in the direction of v will be 1 over 13 times v, which will be 1 over 13, 12 minus 5, which will be 12 over 13, and minus 5 over 13. Okay, now one other thing. These are 1, 0 and 0, 1 are called standard unit vectors. Okay, these are standard unit vectors. So the good thing about these vectors are when you put them in the Cartesian system, it will be this one here, 0, 1, 1, 0, and it will be the other one. So this will give you a unit vector in the x direction, and it will be on the positive y direction here, 1, 0, 0, 1. So this is, we call it, one of them we will call I, x component, the unit vector on the x-axis, and the unit vector on the y-axis, or in the direction of y-axis, will be j. So we will call these vectors I and j. This is a new notation now. So we will try to write everything in terms of these two. So we can use I and j notation to represent the vectors. So for example, I is 1, 0. As we said, j is 0, 1. Now a, b can be written as like 8 times 1, 0 plus b times 0, 1. So these are just numbers here, numerical value scalars. So you know this one here, a times 1, a times 0, it's 0. This b times 0, it will be 0, and b times 1, it's b. When you add them, so you got a and you got B here, so we'll get AB. So this writing is true. I mean, there's A, B. The vector AB can be written as A times 1, 0 and B times 0, 1 vector. And this is now I. So we can write I, A times I vector times B times J vector. So here is the situation. Now, so in terms, instead of writing any vector like 2 or 3, you can write here 2I plus 3J. So it means like this is 2 or 3, 2 or 3. Okay. And if I say like 5I and plus 0J, it means like 5, 0. And indeed, like when it's not written 0 here, so if it is 0, so no need to write J. So you can directly say this is 5I. Okay, we will use the IJ notation from now on. So you should be able to recognize the vector with I and J, without IJ. You should know about the notations of the vectors. Now let's look at here. Yes, this is what I told you. This is V is equal to AI plus BJ now. So IJ are the unit vectors on the direction X and on the direction Y. So the vector operations, we can write the same things with I and J. I components, you add I components together, A plus C, and in the subtraction, you subtract I components and J components from each other, add or subtract. And when we multiply with K, we multiply the both components, K times AI plus J. So this has to be KAI. So here it's bold. So to make a difference, I will make, to distinguish it, I will put a vector here so that it's I vector. It will be J vector here. Now let's look at okay, let's look at the operations here. We can do the operations by using I and J. So the vectors are given here in terms of I and J, and we will perform the operations here. Here you can check them, 2J, 2 times U. Okay, please check them. This is V, and then be careful, minus 2I, and minus minus, it will be plus. So please have a look at them and try to do it by yourself and check the calculations. In the last one, we will find U plus V. U is, we know, 2J, and this is 2I minus 4J. And then when you add them, 2I, nothing is here, just 2I, but 2J minus 4J, it will be minus 2J. And our vector will be now 2 minus 2. And this is how we take the magnitude of it. So 2 squared plus negative 2 squared, square root. So it will be 2 squared 2. Now we will see another operation on the vectors. This is, we call it dot product. Now let U be A, B, and let V, the vector, be B, has the components C and D. And then we define the product of U and V as, okay, we denote it as U dot V, and we multiply the X components and we multiply the Y components and then add them. So this will be the dot product of U and V. It has some use in physics, and we will see its application here as well. Here, let's do some examples here. U, V. So let's do the dot product here. 3 times 2 plus minus 4 times minus 5, 26. And U dot V here. So if it's written this way, like AI plus BJ times dot product, like AI plus CI DJ, so you can directly multiply these two and these two. The thing, okay, here, one other thing I want to say is this is I, this is J. So when you dot product, you multiply this. Okay, I forgot to tell you this one. You can do this multiplication, but one thing you will get here is this. When you multiply AI with DJ dot product, you will get this is equal to 0. So you will eliminate you will see some zeros here, and after the zeros you will end up with this. Okay, it will come to the same thing. Now, how can I multiply these two? It will be AI. Sorry, this is 2i minus 5j is 2 minus 5. Negative 3j is this. So you do this multiplication. Now, we can use the dot product to find the angle between two vectors. Now, look at here. This is the formula. The formula is theta is the angle between two vectors u and v is we can be found by cosine inverse of u dot v divided by the magnitude of u times magnitude of v. So here, since we use cosine inverse here, of course, the range of cosine inverse, the output for cosine inverse, as we know, from 0 to I, so it means 0 to 180 degrees in terms of degrees. So it will be this. So this formula is telling us the angle between u and v. So the question is, like, if you have u and if you have v here, so what is the angle between them? We know the components of u, we know the components of v, assume. So there are some numbers here and some numbers, and so how can we get the angle? This is a nice formula in terms of, the components. It will be very easy because finding the angle between two vectors is not very easy to do, but with this calculation, it makes it very simple. Now, let's look at the angle, these vectors, and let's try to find the angle between two vectors here. One is given in standard form with numbers and the components, with usual notation, and the other one is the IJ notation. So this indeed, I want to remind you, this is indeed 2, negative 3, and this is 6, 4. Now, keep this in your mind all the time. This I and J notation means this. Now, let's use the formula here. U dot V. U dot V is what? Okay, you multiply the x components and y components and add them. And the norm of u is, we know, take the square, and take the square root. Add them, take the square root, and b, calculate, and you will get cosine inverse negative square root of 3 over 2. So, sorry, so I will do this one now. Cosine inverse of negative square root of 3 over 2. So this is, how we calculate quickly. The first thing is this angle will be between 0 to 180. We know 0 to 90, it will be just positive. Cosine will be positive. So you can directly say, hey, this has to be between 90 and 180 degrees, for sure. So we are looking at an angle between 90 and 180. So this makes quadrant 2. And you look at which angle has, okay, regardless of minus, you don't take the minus. So which angle here makes square root 3 over 2? And as an acute angle, it will be 60 degrees, 30 degrees. And you will try to find an angle here in the quadrant 2 and with the reference angle 30. So it will be, our angle will be 150 degrees. So you say this has to be 150 degrees. Okay, please look at 1.6 questions in the slides. You will see how we do it. Now, let's look at the other one. U dot V is equal to here 0 for the second one. Now, no matter what the norm of or the magnitude of U and V, since we have 0 here, so it will be cosine inverse 0, and cosine inverse 0 is 90 degrees. So we get this type of situation here. So it's 90 degrees. If u is here and v is here, it's 90 degrees. So they're perpendicular to each other. And from this calculation, you will see u dot v is also equal to 0. So we see if the dot product is equal to 0, then they're perpendicular to each other. Now let's look at another application of trigonometry.